Hello, folks, and welcome to Advent of Code in F Sharp, day 7. Or should I say, day 7, take 2, because gee whiz, this was a hard one for me. I had a stream for 90 minutes where I was flailing around and fighting against a Stack Overflow and an infinite loop. And yeah, I didn't get the end result on stream. But then I took a second look after I had a break and I found my bug. So I decided to upload this short video to go over the end result and to discuss the new concepts I used for day 7, because there's some interesting stuff in there. I will still upload the entire 90 stream fight against Stack Overflows, but I suggest you only watch that if you want to see someone experienced still struggle for more than an hour on a on a stupid bug. It's still a thing. As long as you write code, you will have moments like these. So yeah, but let's go over what I did for day 7. Quick recap: day 7 is no space left on device, and it's where our inputs are change directory and list current directory commands, and we see like which files and which directories are available. And at the end of part 1 and part 2, we get asked the question, figure out which directory we have to delete to free up enough space to, I don't know what the description mentioned again, but we have to figure out the biggest directory or the smallest directory we can delete, something like that. So yeah, I suggest you go and take a look at the problem description yourself if you want more detail. And let's dive into the F-sharp solution I came up with. So as you can see, I do a lot of parsing. I parse every line, here we go, into one of two things. It's either a command or it's an output. Commands are the cd and the ls commands, and outputs are the files, and a file info or a file output line lists the size of the file and the file name, and a directory just lists the directory name. So let's take a look at how I parse our input, or how I parse every line. This is the parse function. It takes a string and it returns one of those line types we just saw. But the interesting part here today is, as you can see, there's just one single pattern match statement in this parse function, and it's matching on isCommand or isOutput. And if you take a look at where we define isCommand and isOutput, you'll see some very weird syntax. These parentheses and these pipe characters, and then this underscore thing. This is called the partial active pattern, and it was made for things like this, like pattern matching on a line where it can be one or the other, but you want to have an open-ended list of things and not just pattern match on one union type. Then these partial active patterns are amazing, because you can keep on adding new ones without having to change the union type. But I digress. So this is a matching on commands. We just take a look at, does it start with a $sign and cd, or does it start with ls? I realized at the end that we don't even need these ls commands. We don't do anything with them, we just ignore them, but hey, we parse them either way. For the rest, there's not much interesting going on in parsing world. Then, what's the next thing? The next thing is building the directory tree from these parsed input. So let me quickly go to our solve function. Yeah, sure, that's a good next step to take a look. So this is my solve. I think for part 1 and part 2 partially builds upon that here. So solve, take it with a grain of salt, but this is the main algorithm. First, we parse the lines with the parse function we just discussed. And then we fold again. Here's our good friend list.fold. We fold over something I call state. And we use a function called process line. So let's take a look at that. This process line and this state thing is how we build the directory tree. So state, what does that look like? State is the thing we thread through the fold, and that's a tree, or rather I called it tree, but it's not a tree, it's a lookup, a dictionary, or in F# we call it a map. And it maps paths. A path in my implementation is a list of strings, like folder names appended in a list. And what's at a given path. So that's a list of files or subdirectories. So that's what this tree thing is, sorry. And current path is just like an instruction pointer that points to the current path we're visiting while folding over the instructions. So let's take a look at process line now. That's the basic fold function, or the function we fold with. And that's just a pattern match on every line. If it's the ls command, we ignore it. We just return the state untouched. And in all other cases, we need to do something, or we can do something interesting. If we do cd ... we go up a level. So that means that just the current path shortens by 1. If we cd into a directory, so we descend in the tree, we grow our current path, so we append dir to the current path. And if it's an output line, so if it's a file or a folder line, we just insert that node, so we insert that folder, subfolder, or we insert that file into the tree or into that lookup table. So insert here, how does that work? We just look at what's at the path currently. If there's nothing, okay, that's the first thing we found at this level of the directory structure. So we just create a new list with just a node. And if we already have something at that level, we just append the node to the existing thing. So that's also pretty self-explanatory. And what's the end result of this process line folding magic? We get our tree, or our lookup table. It's not a tree. Shouldn't have called it tree. But I did, so here we are. Next step is just figuring out all the folders we have, so we can find the smallest folder we can delete while still meeting the constraints. So that's just all the keys I have in my tree structure over there. And then we just calculate the size for each and every folder we have. And then we do some maths, sorting, but that's not the important part. That's pretty basic. Let's take a last look at calculate size. And this is where my 90-minute previous attempt, or my original attempt, went completely off the rails, where I introduced memoization because I thought it was a performance problem. It was not, it was a bug. So I ripped out almost everything I did in the last hour of that stream, and it's pretty basic now again, which is a good thing. So what does this calculate size thing do? Given a path, or so like a // thing, and the whole tree, calculate the size at this directory at path. So we look at all the elements inside that subdirectory. It can be files, it can be subdirectories themselves, and we just sum the sizes of each of those child items, and that's it. So it's pretty basic. You'll see let rec here. I think that's the first time I used the rec keyword this year. It's just defining a recursive function that can call itself. But I thought, hey, this isn't enough. Let's make it even more complex, and let's introduce mutually recursive functions. So that's a recursive function and another recursive function, and they can kind of call each other recursively. And because F# is pretty strict about you need to have defined a function before you can actually call it. That does not work very nice if you have functions that call each other's circular dependency-wise. So that's why this AND keyword exists, and why we need to do this if you want to have mutually recursive functions. Or at least it's the most elegant, most straightforward way of introducing mutual recursion. But yeah, so that was calculate size, and size of is the other part of the solution where we actually take a look at what we have given every node. If it's just a file, great, no extra work. We know the size of a file. It's right there on the line. And if it's a subdirectory, we need to figure out the size of this subdirectory. And this was what cost me an hour. I had a bug here, like if you have this, that's the subdirectory name and not the entire path, and that was what took me an hour to figure out. But yeah, I figured it out. So this is the full path of the subdirectory, and we just need to recursively calculate the size of that subdirectory and go ahead. So all in all, it was a really fun puzzle. I was staring at the bug at the wrong direction for an hour, so learning moment for me to take smaller steps again. I really enjoyed today's puzzle. We introduced some new concepts, so yeah, great success, I would say. That's it I have for today. If you really like seeing someone struggle, you can always take a look at the full 90-minute take 1, and otherwise, I hope to see you tomorrow on Advent of Code and F#. Bye bye.